So yeah, let me.
This meeting is being recorded.
Perfect. I have the pleasure to introduce the first keynote speaker of the day. So it's my pleasure to introduce Mladen Nikolic. I'm probably mispronouncing the name, like I've been doing yesterday as well. So he's a professor at the Faculty of Mathematics in University of Belgrade, where he finished his PhD as well, and he's gonna talk today about fairness from his biased introduction to fairness. So I'm really excited to hear more about it. So Mladen, you have the floor.
Hi everyone. Thank you, Razvan, for the introduction. Actually, you pronounced my name perfectly, I would say. Thank you. Also, I would like to thank Petar for inviting me and all of the organizers for their effort. So I will give you this biased introduction to fairness in machine learning. Since the whole lecture revolves around bias, I wanted to acknowledge my own in the beginning. And it is biased in two respects. The first one is about selection of the topics which are close to my experience. And also there's one slide on my work. And also there's another kind of bias. I think that it is rather hard, at least it is for me, to speak about fairness without any value judgments. So you will certainly be exposed to some of my values, and of course you need not agree with them. Okay, so this is the overview of the talk. So first I will talk in broad terms about unfairness in machine learning and give some examples. Then in the second part, I try to stress that ethics and societal issues come before the technicalities, and technically minded people like us probably should be reminded from time to time of something like that. We are most passionate about algorithms, about model statistical performance and such, but there are other stuff also to take care about. The next part, I first titled Notions of Fairness. But then in the light of the discussion that will go before, I think that it is better named technical simplifications of fairness, just to be aware of it. And then I talk about some methods. This is proper technical stuff. And then I give some takeaway points. Okay, so first about unfairness in machine learning. So we can see machine learning around us pretty often. We use some kind of machine learning models maybe every day. Like I use from time to time machine translation services. Some people use personal assistants on their phones. We are exposed to recommender systems whenever we are watching videos or shopping online or etc. I use face recognition systems whenever I unlock my phone. The information retrieval services are something that I use probably every day. And we are probably all fine with these applications, and they help us in various ways. However, the artificial intelligence is making steps into critical aspects of the society. And I guess we can agree that the previous ones are maybe not that critical, but if you think about decision-making in health, legal, employment, and security, I think that we could agree that that is a little bit more critical to the functioning of the society. And that would actually make us vulnerable to the errors that our models could make. But what are the expectations of the AI regarding fairness, bias, etc.? So we can say maybe that mathematics is rigorous and unbiased. You will prove that something holds. You will perform a rigorous analysis, and then you can be sure that some claims are actually true. And we use mathematics to build and analyze artificial intelligence. So we expect that it will inherit these properties, and it has no agenda of its own. At least we think so, right? Therefore, there's an expectation that it can actually might help us to make good and unbiased decisions. But the reality is a little bit different, because machine learning models, they learn from data. And data is generated in different ways, but pretty often it is generated by human activity. And humans have different kinds of biases towards different groups of humans, other humans, right? And therefore, the data has such biases also. And then when machine learning models learn from such data, they also learn the biases, and they can actually perpetuate discrimination against historically discriminated groups of people. There are several examples of controversies regarding fairness in machine learning that I will discuss briefly. One of the probably most famous one is the COMPAS system, which was used in US courts to assist the judges while making decisions regarding the release or detentions of the defendants. And it does that by estimating the risk of a person reoffending. And what was found in one analysis, you have the reference there, is that it has higher false alarm rates for African Americans than Caucasian individuals. The company defended this product on the grounds that it has another fairness metrics which it respects, but in my opinion, it's not really the best one. Then regarding face recognition systems, US National Institute of Standards and Technology conducted a wide analysis of face recognition systems, and they actually discovered that many of these have wildly different error rates across demographic groups. And this is often cited. One thing which is not so often cited is that the best ones actually do not. So it is a good thing that there are good systems which do not have these kinds of errors. But on the other hand, you don't really know which systems get deployed where and which system will be used in practice in the applications that you are concerned with. And also looking through the lens of a digital camera, Eastern Asians blink more often, except that they do not. Then Google Translate, there's also well-known example. In translations, it discriminated based on gender. When translating from languages which lack grammatical gender, like Turkish, for instance, there's an example in Turkish, to English, of course, where you do have grammatical gender. So if you type in "o doktor," then it will translate as "he's a doctor," but if you write "o hemshire," then she is a nurse, and you can say see the same pronoun "o" for third person. And this was fixed by providing translations for both grammatical genders in parallel. So yeah, okay, good effort. Another example is concerned with job advertisements. There's a case when an algorithm was used to promote jobs in STEM fields, where we know that men are predominant, and there was an honest effort that the advertisement was written in a gender-neutral way. However, the effort was undermined by the algorithm, which actually deployed it in gender-biased way. Okay, so these are some examples, but we may ask ourselves, so what's next? What's coming? What when this happens in the health diagnostics or maybe in autonomous vehicles? So if an autonomous vehicle does not recognize people of specific demographic groups, then it might endanger them in traffic, etc. So the problems can get even worse than what is cited so far. One question that I guess we should ask ourselves from the beginning is, how did this happen? First of all, I strongly believe that such behavior of the models was not intentional, actually, but I don't think that makes things easier. I actually think that it makes them harder, because if it was intentional, then you just need to impose some kind of regulation, training, etc. But this can actually be a little bit more tricky if it is not. But important factors are certainly human biases, which are present in the data, and that's well known now, and also a narrow approach to problem solving. Like, we are concerned with generalization power on some training validation test splits, and it works nicely. Then we test it a little bit in the wild, etc., and then we deploy it. But it is a kind of a narrow approach which abstracts societal issues. Also, there are differences in power and in interest of different groups. So some people are simply in position to produce and to finance these kinds of systems. And if it were their group which was hurt, then maybe it would be detected earlier, maybe it wouldn't happen at all. But also there might be another thing that we should be maybe thinking about, is that technology is often ahead of our understanding of society and our ability to organize it. So often we take society for granted. Like, there are ecological disasters and climate change that we are able to affect, right? We have the technology, we have the power. However, we are still not very good in organizing society in ways to avoid that. Also, we have nuclear power, but which also gives us, besides electricity, it gives us nuclear weapons, which we are obviously not mature enough to handle. Actually, if we were mature enough, we wouldn't need nuclear weapons. And also, one thing that crossed my mind is social networks, for instance, which are a kind of a public space where we discuss, where we work, where we, I can say, maybe live, right? But the governments are not catching up really with the speed of the development, so they're leaving the regulations of the public space, which our public spaces are usually regulated by laws passed by democratic procedure. But on social networks, these public spaces are actually regulated rather often, by corporate policies, which is not really a democratic procedure. So might this be happening with artificial intelligence? And we could be asking this question in probably in different contexts also, besides of the context of fairness. And there's also a natural question of what should be changed. These are some opinions. Maybe somebody else can have much smarter suggestions. But it seems to me that once a technology has reached maturity, which allows it to influence human lives, then societal aspects should take precedence over some technical stuffs. So there should be a kind of a shift from utility towards societal issues like fairness. And I'm not saying that we should stop producing new models with better generalization performance, but that we should be very much aware of the societal issues. And I will speak about that a little bit later, what we need to think about. Also, inclusion of social scientists into system planning and testing is probably a smart thing to do. And being aware that incremental technical improvements probably offer less than what a change of perspective might offer. Then a bit about ethics, and society actually, which comes before the technicalities. So what we do in engineering when we are designing some kind of system is that we are focusing on high utility with respect to some metrics, which we consider very relevant. We take care of scalability, portability, ease of maintenance, modularity, all the nice stuff. But obviously that is not enough for fairness, because these practices were most probably followed in these examples that I already mentioned. So there's a question, what should we think about actually? Well, first of all, and probably I think that we should be thinking a lot. Maybe the best way to solve something is not at all through technology, but through societal change. And it might be a dangerous idea to think that we just need to wait a little bit more for the right technology to appear, and then with enough of those light reflecting particles in the atmosphere, climate change will be solved. Important question is this achievable in due time, and will there be damage that will be, which will hurt a lot of people and maybe even irreversible? Then another question, and I will be borrowing heavily from Timid Gebru's talk from NeurIPS and from a paper of Andrew Selbst in the following slide, because as a technically minded person, I'm also not very apt in these kinds of aspects, but I thought that the message deserves to be circulated. So the question is that we can build a system which does something, but should we? So sometimes the best way to ensure fairness of a solution is not to build it. Maybe we shouldn't have state surveillance systems based on artificial intelligence at all. Maybe there's no point in rectifying their fairness, and something that they can do is maybe much more dangerous and unfair than what we are trying to fix. And also, if they exist, should we terminate them? Also, one more thing that technically minded people are probably not very often thinking about is whose values are actually being incorporated in the system when the design decisions are being made. The metrics are actually value laden, and the data is value laden, as we have discussed, and I will reflect on the metrics a little bit later. And also, some groups of people, demographic groups, generate much more data than the others, and the data will reflect their value judgments. So if you consider how natural language models are trained, you will probably gather some kind of text from the internet, maybe Wikipedia, maybe newspapers, or etc. But it is a rather small group of people who is writing these texts. I'm not saying with any bad intention, but those are probably people who are a bit more educated and a bit better off, and it will reflect their value judgment. So the system that you will build will probably not benefit everyone the same. Another issue which is being raised is the issue of abstraction. So as engineers, we manage complexity by building hierarchies of abstractions. And that gives us the modularity, scalability, etc., which we in engineering pretty much like. But abstraction means disregarding the details. And if you think of a system as something which takes inputs and gives you outputs, which is often done, then you're abstracting a lot about the context in which this solution will be operating. The societal context will probably be the first one to go. So which details actually get disregarded heavily depends on the individuals which are making this abstraction and on their values. And what are the pitfalls of abstraction, as has recently been discussed? First, are the relevant societal factors abstracted away? The solution that we are building using machine learning is actually embedded in some kind of societal context, like it is a part of a legal system. Okay, it does not work in isolation. Are our fairness metrics adequate? I think that it can be argued that the one which was used in the COMPAS is not. And also, are there actually crude simplifications of what we actually consider justice? Just imagine a court deliberation, how many different details and how much of the context it takes into account. It's not something which is easily measured and put into the model, at least not yet. Also, can we predict the reaction of the societal actors when this solution is introduced in social contexts? And also, can the solution be ported to another societal context, one when you abstract a bit less for it to adapt to the societal context, it is less portable. So, and all of these things should be thought about. This leads to so-called sociotechnical perspective. The machine learning models are subsystems of social systems, as I already mentioned. So it is not a technical system anymore, but a socio-technical, because it will include some institutions, some humans, etc. And fairness is not just the property of this technical tool, but actually of the whole system and the process that that system serves. So the advice is, and I'm not saying that it is an easy advice to follow, to include deeper societal considerations, and that this abstraction boundary should be drawn further away from the technical core and into the societal frontier. Okay, so now we can get a little bit more technical. I will be speaking about actually notions of fairness, but emphasizing that those are actually some technical simplifications. First of all, fairness considerations are as old as human culture. They have been discussed by philosophers, social scientists, religious leaders. So it is not something that we are inventing for the first time at all. And we are actually just trying to formalize these notions in terms of some statistics which can be computed from the samples of what our models are producing. And there are two main notions in machine learning fairness literature at which we focus. And those are the notions of individual fairness and group fairness. Let's take a look at what they are. And there will be metrics which reflect these notions. And as I said, the metrics are value laden. You will see how these notions of fairness differ, and therefore the metrics too. So first of all, individual fairness. The main tenet of individual fairness is to treat similar individuals in a similar way. In technical terms, similar feature values should yield similar values of the target variable. There's of course a question which similarity measure should be used. It might be slippery, maybe not, but it is something to decide on. But there is another issue with this. Individual fairness might be well aligned with the utility. But on the other hand, it does not it stays silent with respect to historical discrimination. So two persons which belong to one race may be similar because they're, let's say that they're taking a loan from the bank. They might both be poor or both be rich, right? But history has a lot to do with that. Historical discrimination towards that group might be a reason that they are poor. And from the perspective of the bank, they're simply deciding based on the economic status, and they are individually fair, but that does not help historical discrimination that I have mentioned. But the metrics that we are using here, here are two, one a simple one and a rather interesting one. First one would be to take all of the individuals from a set of individuals. Of course, their representations in terms of features. Then we see the treatment which is predicted by the model. And if these are similar, if the individuals are similar enough, then we check the difference between their treatments and we sum or average, and we expect this average difference to be rather small if the model is fair. Otherwise, it could be big. That's a pretty simple, I think, and intuitive choice. But there's one rather interesting approach, and that is counterfactual difference. Counterfactuals are probably mentioned yesterday when causal inference was discussed. So the idea is to measure the difference in the outcomes for a specific person if the sensitive features of that person change, like the gender, the race, or something else. So if something would be different, if just those sensitive features change, but actually all other features are the same, and all of the unobserved features are the same, then that is a sign of unfairness. The issue with this is how to model how an outcome would change if a person had different features. And this requires actually causal modeling, and causal modeling is not easy stuff. So this is a little bit, in my opinion, more of theoretical importance, but I believe that causal inference actually holds the key of individual fairness. Then there is the notion of group fairness. It says that we should treat different groups of people equally. It aims at mitigating historical discrimination, but it actually might hurt utility. So if you imagine that two demographic groups differ in their economic parameters, one of them are better off than the others, then a bank which should respect this group fairness should actually give loans to poor people a little bit more often, and they would operate at higher risk, and then the utility would suffer. I think that we could say that this individual fairness notion actually would appeal to people who are economically liberal, and this one might appeal to people who are actually economically leftist. So there is a lot of value judgment being performed here, and actually ideology. Group fairness metrics, there's, let's say, several of them. And they're expressed in terms of some differences of frequencies of positive outcomes for different groups of people. And there are three notions which are achieved when these metrics are zero or, let's say, low. The first and rather simple one is demographic parity. It means that you will be providing the positive outcome to the members of two groups defined by this sensitive feature S, possibly 0 or 1. And you are equally frequently offering the positive outcome to both groups. It has been criticized as rather crude notion of fairness, but all of these notions of fairness have been criticized. The next one is equal opportunity, which is a little bit different. It is a difference between true positive rates. So if the treatment for a person should be positive, is it really positive? And you are making a difference between different groups on average. And also there are equalized odds, which also, besides true positive rates, take care of the false positive rate, meaning is one group getting the positive treatment more often than the other when it shouldn't? So it is a measure of privilege, actually. These are equalized odds. And one well-intentioned idea might be, let's optimize both individual fairness and the group fairness. But as you might have already understood, these are actually incompatible, and it has been proven so. And actually, the metrics that you can introduce within the same group are also incompatible between themselves. So you cannot optimize them simultaneously, maybe to some extent, but not fully. Therefore, we faced some trade-offs, and I think striking a balance should be at the hands of a larger society. But let's point out that if this is not really regulated, it is likely through a democratic procedure, it is likely that the people managing the technical systems will have the say of what kind of fairness is being followed, if any. Okay, so now we can speak a little bit about the methods. First, about group fairness methods. A naive approach to fairness would be not to use sensitive features at all. So the model will not, the training algorithm will not have access to race, gender, whatever the sensitive feature. And this is called a fairness through unawareness. So if it doesn't have the access, the model does not know anything about it, at least we hope, but that is of course not the true, and this fails pretty quickly. Because other variables can be correlated with the sensitive variables, like our cities are clustered sometimes with respect to race, ethnicity, or something like that. So an address where a person lives might tell something about their ethnic background or something else. So another approach is fairness through awareness, and it assumes that sensitive variables will be used by the learning method to control for the bias. And that is actually an approach which is being used in the last 10 years. And we have different kinds of these group fairness methods. There are pre-processing ones, which manipulate the inputs, and then they are oblivious of the downstream algorithm, and you hope that manipulating the inputs is enough. Then there are in-processing methods, which adapt the optimization method, and you perform end-to-end optimization of the objectives that you believe are important. And there is post-processing, where you train the model in a regular fashion, but then you manipulate its outputs in order to rectify a bias if it is detected. I will give an example from each of these categories. So there are the pre-processing ones. So in case of statistical independence between sensitive feature S and the target variable Y, we know what would hold, that the joint probability can be factorized as a product of marginal probabilities. So one idea to compensate for the violation, if it exists, weight all of the instances by this ratio. And it obviously aims at demographic parity as a notion of fairness that we mentioned before. One thing that I like about these kinds of weighting methods is that they are in some sense interpretable, because I can check the weights and they might indicate that, yeah, this instance is maybe more biased than some other instance. And both good and bad thing is that they're oblivious of the downstream learning algorithm. It is good thing in terms of abstraction, right? So I don't need to think what is the algorithm which follows. But on the other hand, you do not have end-to-end optimization of the objective that you are actually trying to optimize. So it might not be that a great thing. Another branch are in-processing methods, and here I give one where I'm a co-author with others of my co-authors, and Andrea Petrovic being the first one, and I've seen Sandro in the audience. And the idea here is to adversarially learn these instance weights, so that from such a weighted training set, we can learn efficiently to predict Y, but we cannot learn, even by the best classifier, predict the sensitive feature. We do in-processing, okay? So the optimization method is designed in such a way to do this, but we are borrowing this weighting idea from pre-processing. So there are other methods which are actually learning fair representations or some other stuff, also adversarially. They do not connect with the weighting idea. So what we see here is you can see, okay, we are minimizing this negative log likelihood for the prediction of y. So we are trying to predict the target variable very well. On the other hand, here you see the maximization of the log likelihood. So we are trying to predict also the sensitive features as well as possible, but within, let's say, this inner loop. However, this maximal performance of this prediction of sensitive features is actually being minimized over the weighting function. So even the best performing predictor of sensitive features should fail. And we have this hyperparameter alpha here, which balances, makes the trade-off between these objectives, because you will be hurting utility, as I said before, when you are aiming for the group fairness. And this formulation also aims at demographic parity, but it could be tweaked in order to follow some other notion of fairness from the group fairness paradigm. We haven't dealt with that, but there are ways to do that. So one nice thing here is that you have an end-to-end optimization of your objective, which is good. And also we keep some interpretability with these weights that we have. Then there is a post-processing approach. And the idea here is to modify the classification thresholds after the model has been trained. And you know that the models often offer us some scores which tell how confident the model is that an instance belongs to a specific class. So like logistic regression has a threshold of 0.5, right? But we could modify these thresholds, right? And then observe the true positive rates and false positive rates, which are actually ROC curves. But if you remember, our equal opportunity and equalized odds metrics, they're actually expressed in terms of true positive rates and false positive rates. So we can plot the achievable regions of these classifiers for different groups of people defined by sensitive features. And then from these ROC curves, we can see how to interpolate between within the achievable region to obtain a classifier with the performance parameters which satisfy actually equal opportunity or equalized odds. And it is this kinds of approach is limited in what it can do by the quality of the upstream algorithm, the one which has been trained. But it's a nice idea, I think. Okay, and there are individual fairness methods. I will go rather briefly through them. So we assume that we have some kind of similarity between the individuals, as we have already said. The main tenet is to treat similar individuals in a similar way. But also we need some kind of, it is a distance in this case between the individuals, but also we need some kind of divergence measures, divergence between the probability measures, the conditional probability measures of y given x. And we impose Lipschitz continuity for this divergence, for this actually, for this, the model that the probability measure that we are modeling. So we want to optimize the negative log likelihood, so to predict as well as we can, but imposing this constraint that the probability measures for similar individuals will not be very far apart, the conditional probability distributions. And just briefly, counterfactual fairness that I mentioned before. So it minimizes that counterfactual difference that we mentioned, meaning that the models will predict the same even if the sensitive features change, but nothing else actually changes, nothing of relevance. And we consider sensitive features something which is not of direct relevance. This actually means that the sensitive features should not be the causes of the prediction. And that sounds fair. But as we already said, causal inference is hard, but this idea somehow makes the best, because you need to have a causal model, right, which tells you how all different variables depend on the other variables. And that is not something which is easily modeled. You have to make a lot of assumptions, and those assumptions are probably not the right ones. But still, I'm looking forward to the time where we have, to some extent, solved causal inference, and then that we can do fairness in this way. Okay, just to provide some takeaway points. So, as I said, maybe the technology is again ahead of our understanding of society. At least I have such kind of impression. As I said, there's a growing, opinion that we should shift focus from technical improvements, at least in fairness-related field, from technical improvements to societal considerations. There's a warning that abstraction can be tricky. Some kind of abstraction is necessary, but the question is, have we abstracted the relevant parts? And sometimes we don't think about the relevant parts. And that we should think who benefits from specific design choices, as each design choice is value-laden, and who is getting hurt by them. And we should also be aware who has the power to decide about these topics for the benefit of democratic procedures. So that's what I had in mind for today, and I'm open for your questions.
Thank you so much. That was an amazing talk, and like an extremely important topic. And it also reminds me of one of the reasons why we started the EML series, because as you mentioned, like the ones who are building the tools will encode their biases in those tools. So it's important that this expertise of, this ability of building tools be spread around, so that, like, say in Serbia, we're not relying on tools built in US, because there's going to be some changes, some misalignment in terms of how societal values. So just a reminder for everyone to post their questions. So there is a question from Andrei. So he says, I have a question regarding the use of protecting characteristic in ensuring fairness. Due to GDPR, using these characteristics in predictive models is forbidden, so as to prevent discrimination. However, there are still latent variables that encode the effect of gender, for example, on a classification. What is your view on this issue? Should we or should we not use protected characteristics?
Well, this is, it was something else, sorry?
No, this is the question.
Okay. First, Razvan, thank you for the compliments, and I'm happy that the talk fits the concept of the workshop well. Regarding this question, I'm sorry, I have a resonance. I'm hearing myself. I apologize. Regarding these questions, I think it directly aims to that question of fairness through awareness or fairness through unawareness. We have seen that fairness through unawareness does not actually work, so it actually tells us that we should really be aware of these features. So maybe the GDPR is actually lagging behind. I already said that state imposed regulations are often lagging behind. So what we know from the algorithmic side and from evaluations of these models is that we should actually be aware of these protected features and use them to control the bias.
Thanks a lot. So another question from Steve. So he asks, do you think that the current XAI algorithms can help shed some light on fairness of ML models? Or these XAI approaches are not yet that reliable, so we can assess fairness biases using them?
I believe that's explainable AI. Actually, I'm always in favor of explainability and of interpretability. And as you have seen, my small contribution and of my authors to the field was actually related to improving interpretability of these in-processing methods, because if they are based on a learning fair representation through a deep network, then you cannot interpret anything in that representation. These weights, they are of limited interpretability. So we were actually exactly guided by the idea that explainable AI can actually help in fairness. And then we also inspected the weights and the instances, and we could observe, this seems like some bias being present here, etc. The field, the explainable AI field is something which is, of course, growing, but for more complex models, maybe still in its childhood. So I'm not sure that I can say that it can do wonders for fairness, but I think that it is pretty much the right way to go.
I have a more technical question. Maybe it's a ill-posed question, but like thinking particularly of the algorithm from the work you were involved in as well, where you had sort of that kind of adversarial objective. I'm wondering, is there important to make a distinction between learnability and representation? So one thing that's happening there is you're showing that some classifier cannot learn from that representation to extract the feature you want. But that doesn't mean that it is not within that representation. It could be that just the optimization process is failing because learning is non-convex and there's lots of issues with that. And you have the other branch where that issue might not happen, that failure might not happen. I don't know, from a more like mathematical theoretical, do you think this is a concern, or do we need to worry about this kind of thinking?
Yeah, I love these questions because I never thought of it. But I think that it is something that you should keep in mind. I'm thinking especially when we are speaking about representation learning, it might be a concern, but that's something that I will have to think more thoroughly on. Good topic for future work. Thank you.
Okay, great. And then, sorry, just sort of for the last question, something a bit more general. So a lot of fairness work is focusing on the form of discriminations that we're aware of, like race or ethnicity or something like that. But quite often, a system might be fairness in a way that we don't yet understand. There might be some factor that we don't understand that we're discriminating against. And this is something we cannot address technically because we're not even aware that the system is unfair.
Yeah.
So this is something that needs to be addressed in a social way. But I'm wondering, like, how what would be sort of your, like, what do we need to do as a society to be in a position where we can deal with this kind of thing? So you talked a lot about, some of these decisions need to be done at the legal level, but there's a discrepancy, I guess, sort of between the awareness that is at that level, say at the governmental level, sort of understanding of what this thing can do, and sort of where the technology is. And sort of as it's a very open-ended generic question, but like, what do you think are the key things we should push for us to be in a better position to deal with fairness in the future?
Yeah, well, okay, I mentioned regulation already, but that's usually slow, okay. One thing, since we are aware that the corporations are the ones which have, access to decision-making and which are producing all these kinds of models, I think that probably the first step is advocacy from within, for them to adopt these kinds of practices. And of course, they are perfectly aware that such things are happening. But I think that among the technically minded people, we often think like societal issues are something easy because everyone can make some kind of a judgment, and we are not aware that maybe these judgments are not so good. Nobody will discuss physics or computer science if they have not read enough books, or at least won't believe that their opinion is very informed one, but we will discuss about society in that way. But I think that there should be maybe a little bit of a bit more openness from engineers and technically minded people towards the societal issues, and maybe admitting that social scientists know a lot more. I've often seen some kind of conservatism towards social sciences among the engineers, mathematicians, natural scientists. So that's why I'm stressing this out. And then within the corporations, this culture can be fostered. And also one thing, we have really a lot of visibility of AI. There's many people who are speaking of AI, right? So different kinds of aspects. Is it dangerous for the humans, etc.? I feel that fairness is not so often mentioned in those talks, so maybe they could help.
Cool. Amazing. Thanks a lot. Yeah, this was an amazing talk, and I think like very, very inspiring topic. So there might be some question on Q&A in the Q&A channel on Slack if you have any time to go on Slack and maybe answer there. But right now we're out of time, and I'm gonna pass to Petar to introduce our next section.